Hello, and welcome to today's presentation on Gefran's IO-Link melt pressure transducers. Thank you for taking the time out of your day to join us for today's webinar. There will be a question and answer period at the end of the presentation. You can write in your questions to the chat window to the right of your screen. And at the end of the webinar, I'll be happy to do my best to answer those questions. I would like to start the presentation by discussing some of the opportunities that Industry 4.0 and IO-Link bring to the plant floor. Industry 4.0 is a vision of the future created by a consortium of manufacturers to help increase their competitiveness through efficiency, intercommunication, and cooperation, using their resources, plants, people, and information both internal to the factory and along the entire value chain. Data collection for analysis can give any company a competitive advantage. What can the sensor offer? The capability of collecting more process data, enhanced connectivity to efficiently transmit that data, and improve maintenance, both predictive and preventive, for both the process and the sensor itself. What can Gefran do as a sensor manufacturer to build on the cornerstone of Industry 4.0? One way, a new communication protocol. However, a protocol for sensors, actuators designed to meet these needs already exists. It's an extension of the globally recognized Programmable Logic Controller Standard, IEC 61131. The IO-Link Consortium was established in 2006. The graphic shown here is a market scenario with data provided by the consortium. It's important to note, looking at the number of IO-Link nodes or devices connected, the exponential growth, specifically a 41% increase from 2017 to 2018. It is estimated that the compound annual growth of 33.5% from 2018 will produce an IO-Link market size in the order of $12.2 billion by 2023. I would like to talk now about some of the main benefits of a melt pressure sensor incorporating IO-Link. Although IO-Link has been around for more than 10 years, Gefran is the first manufacturer to incorporate IO-Link in a melt pressure sensor. IO-Link provides customers with flexibility, productivity, connectivity, efficiency, as well as a safety component. A key component in the IO-Link specification is standard cabling. All devices are integrated in the same way to a common bus. The physical output is a 5-pin M12 connector. Reduced cabling equals reduced costs and provides a space-saving solution. Devices in an IO-Link network are truly plug-and-play. You can quickly replace a sensor and reassign saved parameters that are contained in the IO-Link master to any new device. What are the benefits? Fast configuration, obviously reducing machine downtime. Replacements can be managed by inexperienced personnel, and prevention of incorrect settings. Data is exchanged in an IO-Link network in two ways. The first is cyclical, which is transmitted at predefined times, such as process data, pressure for instance, as well as status values, whether data is valid or invalid. Then there's acyclic, which is only transmitted upon request from the IO-Link master, such as device data can be identification, configuration, auxiliary data, some diagnostic information, events, and alarms. On the next slide, we'll take a look at some of the device data that can be transmitted on the network. Identification parameters are just that. It's very specific information available to the user in order to identify the product. For example, manufacturer's name, the product name, that's the complete code of the product, a part number, some text that can be stored at the time the sensor is commissioned, serial number, calibration date, calibration certificate, application, functional and location tags, and the list can go on. Configuration parameters are used to define how the sensor should work. For example, alarm thresholds. Alarm thresholds for the safety relay if it's incorporated. There's also a pressure peak counter, a temperature peak counter, the engineering unit of the pressure range, the parameterization of the analog output if it's present, the auto zero function, and many others. There are several diagnostic parameters available, such as an error counter, device status, safety relay status, alarm status, and SIO mode. SIO is standard input-output mode, which is the basic operation of the sensor before it goes into the IO link mode. And then there are auxiliary parameters in addition to process data. These are usually specific to the type of device that we're talking about, but in the case of our melt pressure transmitters, they are recording of maximum pressure, recording of maximum temperature, and recording of the working time. These collective pieces of recorded data are crucial to improve the control process and give a view into some preventative maintenance actions that could be due. On the housing of the sensor is a multicolor LED. It will give indication of the current status of the sensor. For instance, fixed green, the sensor is in the standard IO mode. Blinking green, the sensor is in the IO link mode. A single blink of blue indicates the auto zero was successfully executed. Solid yellow is the sensor's in a calibration mode. Yellow blinking is an alarm or an error not related to safety if the safety features are included. Or red blinking is an alarm or error that is relating to the safety if the safety features are included. This gives the ability of an operator or maintenance person, if the sensor is visible from their location, to see its current status. With a device on the IO link network, it is possible to configure and remotely control the parameters of the sensor. For example, with a melt pressure sensor, the auto zero function can be gauged when the machine is at working temperature. All of Gefran's IO link models can be rearranged with a ratio up to 3:1 down from the full scale of the sensor. For example, a sensor with a scale of 0 to 100 bar can be adjusted to a full scale of 0 to 33 bar. This becomes a great flexibility feature to allow one sensor to be stocked for several possible applications. In addition to the Performance Level C certification for functional safety, Gefran's IO link melt pressure sensors can be compliant with the safety guarantee level of SIL 2 and Performance Level D if chosen in the order code. There are two alternatives. A relay output, normally closed, that opens if the pressure exceeds a preset threshold. Of course, this threshold is easily adjusted via the IO link network, or if an internal error occurs in the safety functions, also indicated by a blinking red LED. The second is a certified analog output, either in current or voltage. Now I'll go into a little more detail about all of the models in the series. Gefran offers the IO link output on all four of our sensing technologies and melt pressure sensors. The ILI is our impact sensor, a fluid-free design with process temperature maximum of 660 degrees Fahrenheit. The ILK, our fluid-filled sodium-potassium or NAC-filled sensor with a process maximum temperature of 1000 degrees Fahrenheit based on proper diaphragm selection. The ILW, FDA-approved oil-filled sensor with maximum process temperature up to 600 degrees Fahrenheit. And the ILM, our mercury-filled sensor with maximum process temperature up to 750 Fahrenheit. Our impact sensor is a fluid-free premium sensor, highly regarded in the market as a robust sensor for the most harsh applications. Its diaphragm thickness can be up to 1.5 millimeters or 0.6 inches thick. Pressure ranges up to 15,000 psi, standard accuracy levels of both 1/4 and 0.5% of full scale. The certifications, the safety certifications, and the IO-Link functionality remain the same through all 4 series. The sodium-potassium filled IO-Link sensor brings to the series the ability to reach process temperatures of 1000 degrees Fahrenheit. The FDA-approved oil-filled sensor, the ILW, brings to the series a product for the food and pharmaceutical industries. And finally, the mercury-filled IO-Link melt pressure sensor, the ILM, brings to the series the highest full-scale pressure rating and the lowest temperature drift. As with many sensing devices, there are several criteria that need to be evaluated when choosing a melt pressure sensor. I'd like to review some of these with you now. In general, the list below shows some of the criteria that need to be considered when choosing a melt pressure sensor. There are things like pressure range, process temperature, the in-contact material, that's the diaphragm material, mechanical dimensions, required accuracy, the type of output signal. Does the filling fluid have an impact on the type of application it's going to be used in? The type of electrical connection that's needed? The type of process connection, thread, seating, etc. Is there a safety certification or performance level needed? What amount of temperature drift is allowable in the application? Are there overloads that need to be considered when measuring the application pressure? Choosing which sensing technology would be best for your application is not always a 100% exact science, but based on the plastic being processed, the compound type, we can break down these qualities into 3 groups. The plastic compound will either exhibit adhesive properties, abrasive properties, or corrosive properties. And yes, it's also possible for there be some combination of those, but usually one is more prominent than the others. So based on this, we've produced this little chart just to give an idea of what the best possible choices are in terms of the sensing technologies based on the plastic compound being processed. Once you've chosen a sensor type based on the properties exhibited by the compound as mentioned in the previous slide, then we have to look at the maximum temperature that the diaphragm is going to see in the process. And then, of course, the operating temperature is the temperature range of the electronics housing. and we offer a number of different mechanical variations to ensure that the electronics housing can be mounted a safe distance from the temperature to keep it within the operating temperature range specification. Now I'd like to provide some additional supporting material and some unique information regarding IO-Link. There are a few important pieces of information regarding Gefran's implementation of IO-Link in our melt pressure sensors. The first I'd like to point out is the cycle time, or the equivalent to the response time in an analog transmitter, is 2 milliseconds. That means that the implementation of the digital I/O circuitry to support IO-Link has not affected the response time of our standard sensors. We comply or operate to IO-Link version 1.1. This is the firmware version. This is the current firmware version established for IO-Link. Our transmission type is considered COM2, which is 38.4 kilobaud. Do we support the standard I/O mode? Yes. We are a Class A port in support of a master in a system. Pressure data resolution is a 14-bit resolution. The temperature is 16-bit. And we have a rangeability of 3 to 1 with the optional analog output. The IO-Link device description file is an electronic file that is actually the heart of the IO-Link system. This file is unique to every individual model code that Gefran creates. And this file contains all of the description, information, and identification data that was discussed earlier in the presentation. This file is stored in the master, and it is key to allow the master to be able to connect, to identify and connect to the sensor when it's plugged in to a port of the master. It's also used by the master to make sure that the sensor plugged into that port is in fact matches the data described in this file. This is one of the features that allows any sensor that doesn't match the description in this file to be indicated by an error so that the system is alerted that the wrong sensor is installed in this port of the master. The file contains process data, parameter data, a graphic presentation of the manufacturer, for instance, the logo or a picture. It makes it easy for programming the system and making sure that the correct sensor is installed and identified properly. If you are familiar with the Gefran melt pressure ordering code, you will notice that the IO-Link melt pressure ordering code follows the same flow. I will point out that the configurator or the extension code is required when ordering the IO-Link melt pressure sensors. Starting on the left, you'll see that this code, this example, starts with ILM, which is an IO-Link sensor with a mercury fill. The numeral 1 indicates that this model is going to have a rigid stem with flex. I'll point out for those that have seen melt pressure ordering codes for Gefran in the past that the configuration option 2 does not exist with IO-Link models. The configuration option 2 in the standard melt pressure sensor identified an option with a thermocouple inserted into the sensor as a second output. The temperature output is always available in the IO-Link sensors, that therefore the model 2 or the version 2 is not required. So even if you order the version 0 or the version 1, you will always have the temperature signal available across the IO-Link network. The next series of blocks in the order code indicate the connector type, of which there's only one choice, and that's the M12 5-pin connector. The accuracy class of two choices, either 0.25% of full scale or 0.5% of full scale, and then the pressure range. The next three blocks define the thread, the rigid stem length, and the flexible stem length. The last block in the standard code allows you to select either the standard I/O link or with performance level D in SIL2. The first block in the extension or the configurator allows you to select with or without the integral temperature included. The remaining three highlighted areas of the configurator allow you to select if the auxiliary analog output is present and which type it is, or whether the safety relay output is present. Additionally, you can select if accessories such as a mating connector and mounting bracket are included in the box. It's important to note here that both the auxiliary analog output and the safety relay output are mutually exclusive. In other words, only one can exist, not the other. Now shown is the complete code based on the selections observed in the previous slides. So what this means is a melt pressure transducer with I/O link output, rigid stem, and a flex stem of certain lengths described by the digits, a 5-pin connector with accuracy class of 0.25% of full scale. The measuring range is 0 to 350 bar. The rigid stem thread is 1/2 20 UNF. The rigid stem length is 153 millimeters or 6 inches. The flexible stem length is 457 millimeters or 18 inches. We've chosen Performance Level D/SIL2 certification included, no auxiliary analog output, and the safety relay with a full scale alarm threshold set at 80%. Additionally, the mounting bracket and the mating connector are included in the package with this code as shown. The I/O link master is an essential part of the I/O link network. The I/O link masters provide the connection between the field devices like the Gefran I/O link melt pressure sensors and the machine control system. The master collects the I/O link data from the sensors connected and provides it to the higher level digital bus output. Most common ones are a multi-protocol I/O link master that is easily selectable between Profinet and Ethernet IP. The I/O link master stores the I/O device description file for each of the connected devices and also allows it to be linked to the specific port that the device will be connected to. Gefran doesn't manufacture I/O link masters, but we offer several versions from different manufacturers in our catalog for ease of accessibility. We also offer a selection of extension cables for the I/O link specification in various lengths, including a Y splitter, which is used when your particular I/O link sensor is configured with a safety relay or safety analog output to separate that from the standard I/O link output. The graphic here shows two simple examples of a Gefran I/O link melt pressure sensor connected to an I/O link master. On the left is a standard example, And if your sensor is configured with a safety output, either relay or auxiliary analog output, you could use a Y cable to be able to route that safety signal to its intended location. On the right is an IO-Link master that has a designated safety input block, and therefore you could use a cable splitter type to route that safety signal to the dedicated port on that IO master. And then it would be further routed to where it needs to go in the system. We have focused almost completely on the digital aspect of the Gefran IO-Link melt pressure sensor, but I want to remind everyone that it is still very, very important to take care of the mechanical end or the mechanical side of the melt pressure sensor. Our accessories such as the mounting hole cleaning toolkit and the drill kit are available to make sure that you have access to the maintenance items necessary. That concludes today's presentation, and thank you for listening. You can reach me directly at roger.silva@gefran.com if you have any questions, either product or application. Our toll-free number is also on the screen, and you can also reach out for additional information through sales.us@gefran.com. If you have time and want to stick around just a few more minutes, if there's any questions posted, I'll be answering them shortly. Thank you and have a great day.